If you will be asked to find the sum of the terms of the geometric sequence 1, 1/2, 1/4, 1/8, 1/16, and so on and so forth, do you think you can solve it? You might be wondering how you can get the sum of the terms of the geometric sequence because each terms are infinite. By the way, is it even possible? If you want to know the answer to that question, just continue watching until the end of this video. In the previous lesson, you have learned about finding the sum of the terms of a finite geometric series using a formula. Since the sequence is finite, we can easily find the sum. But what if the sequence has no last term? Can you possibly find the sum? This video will discuss to you how to find the sum of the terms of infinite geometric sequences. To find the sum of terms of an infinite geometric sequence, we will use the following formula. S infinity symbol is equal to a sub 1 over 1 minus r, where S infinity symbol is the sum to infinity. A sub 1 is the first term and r is the common ratio. If we have identified the first term and the common ratio of the given geometric sequence, we can immediately solve the sum of terms of an infinite geometric sequence. Let's have an example. Find the sum of the terms of the infinite geometric sequence 3, 1, 1/3, and so on and so forth. First, we're going to identify the value of a sub 1 or the first term and the value of r or the common ratio. In this example, a sub 1 is 3 and the value of r is 1/3. Can you still remember how to solve the value of r? We simply divide the second term by the first term or divide the third term by the second term. So, 1 divided by 3, that is 1/3. Then, 1/3 divided by 1, that is also 1/3. So, therefore, the common ratio of the given geometric sequence is 1/3. Then, we will substitute the values of a sub 1 and r in the formula. That becomes sum to infinity is equal to a sub 1 is 3 over 1 minus the value of r is 1/3. The next thing to do is we will simplify what is in the denominator. 1 minus 1/3. How to subtract fractions? 1 minus 1/3. How to subtract a whole number and a fraction. So 1 is also equivalent to 1 over 1. And we are subtracting fractions with the similar denominator. So since the denominators are not the same, we will get the LCD. How to find the LCD? In this case, we will simply multiply 1 and 3. So the product is 3. So therefore the LCD is 3. What is now the use of this LCD? The LCD will be divided by each denominator in the fractions and the quotient will be multiplied to each numerator. How? So 3 divided by 1 is 3 times 1. The answer is 3 minus, then 3 divided by 3, the quotient is 1 times 1, the answer is 1. Then 3 minus 1, that is 2. Copy denominator, which is 3. So therefore, the answer of the denominator or the difference of 1 and 1/3 is 2/3. So, sum to infinity is equal to 3 over 2/3. So this time we will be dividing two fractions, or a whole number will be divided by a fraction. So how to divide this one? So I will rewrite that one into this one. 3 divided by 2/3. So in the rule of dividing fractions, we will multiply the first fraction by the reciprocal of the second fraction. So bring down 3, then division will be changed into multiplication, then get the reciprocal of 2/3, that becomes 3/2. Then multiply the numerator and multiply the denominator separately. So 3 times 3 equals 9 and 1 times 2 equals 2. So therefore, this answer is 9/2. So this is now the sum of the terms of the infinite geometric sequence 3, 1, and 1/3, which is 9/2.